Alright, so in this example problem we have car 1, which has a mass of 3,000 kilograms, that has an initial velocity of 25 meters per second in the positive x direction. So that's what I've labeled down here. So this is going to be object 1, so car 1, that's going to move in the positive x direction at 25 meters per second, has a mass of 3,000 kilograms. Car 2 has a mass of 4,500 kilograms and has an initial velocity that we don't know what the meters per second is, but we know it's in the positive y direction. So I've labeled out here. We don't know what V2 initial is, but we do know the mass of the second object. The two cars collide, which is why the arrows come together here, and they move together after the collision, so that tells us we're dealing with a perfectly inelastic collision at 35 degrees above the positive x-axis, but we also don't know what that final velocity is. And our goal here in the problem is to go back and find V2 initial. Alright, so we have a glancing collision. We know it's perfectly inelastic because they stick together after the collision. So the first thing I've written down here is I've written down my x and y direction equations. So we have the momentum initially in the x direction for object 1, the momentum initially in the x direction for object 2, and then our final momentum, so v final x is going to be the same for both because they stick together. And down here I have v1 initial times that mass, and then momentum 2, so mass 2 times velocity 2 initial. And then because it once again is perfectly inelastic, the y component of the velocity for both objects is going to be the same because they are moving as one. So our unknown in this particular problem is right here. So if we try to start with that particular equation that has our unknown in it, we know that the initial momentum of object 1 in the y direction is 0 because the first object is only moving the x direction, so its y component is 0, and taking the 3,000 kilograms times 0 gives you 0 back. So we can plug in the 4,500 kilograms for mass 2. Velocity 2 initial is our unknown. And at this particular moment, we don't know what this final velocity in the y direction is. We can plug in the two masses. But we need to backtrack, and I'll show you how I found this 7 meters per second. So let's go back to the x direction equation, because technically speaking it looks like we're stuck because we don't know what this value for velocity final in the y direction is. Back up here in the x direction, we know the mass of object 1. We know its initial velocity in the x direction is 25 meters per second because it's traveling solely in the x direction. We could plug in mass 2, but velocity 2 initial in the x direction is 0 because the object is traveling only in the y direction. So even though we don't know what that velocity is, we know the x component is 0 because it acts solely in the y direction. So we can plug in 0 here. We can plug in our two masses, and that allows us to find velocity final in the x direction. Now if we go back here to the image that we drew, we can say v final in the x and v final in the y. Now we don't know what the hypotenuse of this triangle is, but we have one side and we want the other side because we want to be able to plug in here, and we have the angle. So that means we can use tangent. Tangent is opposite over adjacent, or v final y over v final x. We have the angle and we have the x component, we found it back here, so we can solve for the y component. I plugged in the y component down here, and that allows me to solve for v2 initial.